Hey there, hi there, ho there, welcome back. Unit 9, so good to see you. Something, we may not think that has any bearing on geology, but it does have an impact, no pun intended, on the geology of Earth. It actually had an impact as well as on the formation of the Earth. I get into that a little bit more in my other Geology 101 class if you're interested. But this unit is all about impacts, the hazards and disasters thereof, etc. So, let's get into this. So here is the Earth and the Moon. FYI, there's only one moon in the whole universe, and it's that one right there. Because that's its name. So the technical term for those sorts of things are called natural satellites. Like a cell phone satellite goes around the Earth. Well, natural satellites go around the Earth. In this case, our one natural satellite is the Moon. So if anyone asks, oh, how many moons does Jupiter have? 0, because there's only one moon, ours. Anyway, complete side note. So this is just a scale reference of Earth versus the moon size. Distance-wise, these things are way far apart. This is just to show you a scale reference of how big the Earth is compared to the moon. Not, in the grand scheme of things, not crazy difference, but there still is a difference there. However, the surface of the Earth looks, pretty much like this, whereas the surface of the moon kind of looks like this. This unit's all about impacts. So, what's going on? Why does the moon look like this and the Earth look like this? Meaning, why are there so many impact craters on the moon, yet there's not on Earth? You ever think about that? The moon is much smaller. So the odds that it would get hit by some sort of space debris are smaller, but yet it looks like it's been hit a whole heck of a lot more compared to us. Well, the reason the moon looks like this and Earth does not is, well, we have an atmosphere. So we get just as many, if not quite more, things heading towards Earth and attempting to hit Earth. Just a lot of that burns up in the atmosphere. Not only that, there's a lot of water on Earth. So there's a lot of things that are covered up. Not only that, plate tectonics is a thing. Plate tectonics moves, shifts, plates go up, go down, get recycled back into the Earth, new crust, new rock. So, due to plate tectonics, due to water, due to the atmosphere, we just don't see those craters. They're either gone due to plate tectonics, covered up due to water, or any of that stuff burnt up in the atmosphere. So that's why the Earth's surface looks like this, and the moon looks like this. The moon has no atmosphere, it has no water, and it does not exhibit plate tectonics. So, and in any case, if you're ever curious, but believe me, Earth gets hit more than, or the Earth attempts to get hit more than the moon does. So, let's talk about that space debris. So, what kind of stuff is floating around space? We kind of give it different names based on consistency, like what the stuff is made out of, what the debris is made out of, but also where it's at. So the first few terms I'm going to break down are meteoroid, meteor, and meteorite. These are actually all 3 different names for the same thing. Remember back when we were talking about volcanoes, molten rock was magma underground, but as soon as it erupted, we call it lava. Just different names depending on where it's at. Kind of the same thing here. Meteoroid, meteor, meteorite. 3 different names for, could be the same object, but just depending on where it's at. So a meteoroid is a lump of rock, metal, or a mixture of both that kind of orbits the sun. So where we can find these things, they're out in outer space. All right, so meteoroids, essentially the kind of some of this stuff of lumps of rock, metal, or a mixture of both, believe it or not, kind of floating around in outer space. That's where we would find meteoroids. Outer space rock/metal. Meteor, the very same object, but a meteor is the streak of light produced by the passage of the meteoroid through the atmosphere. So technically it's still a meteoroid, but the light that it gives off as it's burning up in the atmosphere due to friction, that's the meteor. The meteor is actually the flash of light. All right, so that's in our atmosphere. And then we have a meteorite. A meteorite is a meteoroid that survives passes through the atmosphere all the way such that part of it actually strikes the ground. So we can find these on Earth's surface. So it's called a meteoroid in space. The flash of light as it's burning up in the atmosphere is called a meteor, and that very same thing, once it hits the ground, is called a meteorite. All right. So 3 different names for the same exact thing. And then we also have some other material, asteroids. So asteroids are meteoroids larger than 10 meters wide. So also made up of rock and or metal, but just 10 meters wide or bigger. That's what we call an asteroid. And then we have comets. Comets are asteroids, but with the addition that they're covered in ice. All right. So a little bit different consistency there. So again, comet, an asteroid covered in ice. An asteroid is a meteoroid, so rock and or metal, 10 meters wide or larger. Meteoroid, rock or metal, less than 10 meters. The flash of light as it's burning up in the atmosphere is a meteor. When it hits the ground is a meteorite, and then this is a narwhal. Yeah. So let's go ahead and just pause here. This first section is just a little long, and I don't want to rush it too much. So when we'll pause here, we'll keep this video short. When we come back, we'll talk about where do meteoroids and asteroids, where do they come from? So I'll see you back here in just a minute.